So we're starting the recording. Thank you so much, everyone, for coming to this session. This week and this 1 month, we're welcoming Google Cloud AI team to talk to us about fantastic opportunities that we have in finance for applying AI solution from Google Cloud. You don't need to have a PhD to utilize all the sophisticated tools that machine learning can offer and AI can offer to finance. We're going to have an exciting talk from Russell, who is going to give us some really hands on experience and ideas about how this can be used in finance area. Russell is solution lead with Google Cloud, and he works on data analytics with customers to help them drive maximum value and performance from Google Cloud platform. That's over 20 years of experience in IT area, and the majority of the time is spent with technology design for large-scale analysis. We also have Paul Dearlove. He's a SAP specialist at Google Cloud. 8 years of experience with SAP as the head of SAP digital core business across Australia and New Zealand. And we've got Ben Hutchison, who is an engineering specialist with Google Cloud, focused on showing the value to enterprises from running their SAP and associated data and analytics workload on Google Cloud. We're going to start our presentation, and I'm going to ask everyone to mute themselves apart from the speaker. And if you have questions, please post your questions in the chat. We're going to monitor the chat, and Russell will be taking questions as we go. Thank you so much for coming. Russell, it's all yours.
Maria, thank you so much for the intros, and thank you so much for giving us this opportunity to talk to you all, and thanks all for joining us in your lunch hour. I love talking about machine learning because it is one of those topics that is really interesting once you get into it. Now, I don't come from a machine learning background, which I think sometimes can actually be a plus, because I come at it from someone who's only recently started to understand it. So hopefully you'll come along on the journey with me in terms of the excitement that it generates, and also, as Maria said, also talking a bit more specifically about how you might use it in the finance area. Now, obviously, machine learning is a very broad topic, and today we're going to focus very much on structured data, rows and columns type of data, because that's obviously most of the data that you'd be dealing with. And to be honest, that's a lot of the machine learning work I see in enterprises and across public sector, etc., is to do with structured data. Now, when I first started to get into machine learning, I was reminded of this quote from Arthur C. Clarke, where he talks about any sufficiently advanced technology is indistinguishable from magic. And a lot of people talk about AI and ML as this kind of magic black box where you throw data in one end and then these magical predictions come out the other end. But when you actually start to dig into it, all it really is it's just mathematics. Now, there's some very clever and complex mathematics in there, but it is essentially just underneath the covers. It's just doing lots of mathematics to come up with the predictions that it does. So my first approach to that was, okay, fantastic. I'll jump in there and I'll learn all the mathematics that I need to in order to do this. And what I quickly found was that I was kind of just found myself staring at a lot of mathematics that was taking me back to kind of high school days. And I found myself bogged down in the mathematics, and it wasn't until I took a step back and thought, well, actually, what's my primary goal here? Is my goal to really dig underneath the covers and understand all these algorithms, or am I better off just understanding how to actually use this technology? So what's the best way to feed data into the machine learning machine and then interpret the results that came out the other end? And so when I made that revelation, I realized that actually my time was better spent learning how to actually use the technology. And the good news is that as a lot of research has gone into machine learning in all sorts of different fields, the the old phrase about the rising tide lifts all boats becomes true. So we can all take advantage of a lot of this research that's being done, because all of that kind of filters down to the rest of us, so that, as Maria said, you don't need a PhD in order to start to use some of this technology. The tools become easier and easier to use. And I want to show you a couple of demonstrations later on that will kind of really show you how you can actually start to use some of the technology underneath. So what I wanted to do in this presentation section was just talk a little bit about some of the concepts of machine learning, so that when I show you the demo, you'll have a better understanding of what's kind of happening underneath the covers. Now, I apologize to those of you who do come from a machine learning background, and obviously this is going to be fairly rudimentary, but for a lot of us who don't have that background, I found this really useful. So if you think about the outcome of machine learning, the point that you want to get to is typically that you want to be able to take data that the model has not seen before, give it to the model, and have the model then make predictions based on this unseen data. Now, not all machine learning models work like this, but a lot of the structured models work in exactly this way. So that's where we want to get to. We want to have a model that we can then feed data and have it predict for us. So how do we actually get to that point? So the major step in machine learning is training the model, creating this model to actually allow it to then start to do predictions for us. And so the way that we do that is that we feed the model with the data itself, plus the outcome that we're trying to predict for, so that the model can then learn. So we feed it with the data plus the outcome. That goes into this training step. And then what the training step does is essentially learn the patterns in the data that then produce that particular outcome. And once it does that, what you then have is those patterns are then represented in this model, so that later on we can then start to make predictions. So essentially, we're asking them that in this training step, what patterns in the data lead to the outcome that I'm trying to predict? And I'll give you a more concrete example in a second. You'll kind of see what I'm talking about. So let's look at an example. Let's say we've got a very structured data set that has got every single flight that takes off in the US over a given time period. And what we're trying to predict is whether a flight will be delayed or not when it arrives at the destination. So we want to end up with this flight delay model. So in this data set, so this is just a sample of the data set, we've got each of those rows represents a flight. So we've got the date, the carrier, as in the airline, where the flight took off from, where it's going to, was there any delay leaving the airport when it left, was there a taxi distance that it had to get to, how fast the flight, and then finally the actual arrival delay, which is actually the thing we're trying to predict. So in this context, these columns are referred to as the features. So this is the data that we have. And then the arrival delay, that's the outcome that we want to predict. So that's known as the target. So in the training step, we're including the answers, if you like, so that the model can then learn what patterns in the data or in the features then lead to that particular outcome or target. And then once we do that, and if we're happy with the accuracy of the model, and we'll talk a little bit about that later, we then have our model, and then we can start to feed the model features that the model has not seen, and it will then predict for us the target that we're after. So we could, for example, give it 2 years worth of history with the answers in it, and then from that point forward, we could then predict, say, for the next week ahead, what does the model predict for the outcomes for each of these flights? So at its essence, that's basically what we're doing in this supervised machine learning type of approach. Now, there's a little bit of nuance here as well, which I wanted to talk to you about, because this is where a lot of the work goes into creating a model, is not so much the mechanics of this piece, but you can see here there's a few steps that need to happen before we get to this actual training step at number 5. So the first one, identifying the problem that you're trying to solve, gathering the data. I think that's pretty straightforward. This step here though, feature engineering, this is really interesting, and this is where you can really make a difference to the accuracy of the model that you want to create. So feature engineering is essentially using your domain knowledge about the data set to help to prepare it for training the model. And I'll show you a concrete example of what I mean by that. But often when people are new to machine learning, there's a tendency to say, well, let's throw all the data we have at the model, and the model will just work it out. It will work out what's important, what's not important, and we'll get our answer. Now, that's true to some extent, that the model will filter out things that are not relevant, but that will take a lot longer, and potentially you won't get an accurate result at the end. So you want to be able to try and just massage this data set a little bit to help the model with its job. So let me give you an example of feature engineering in this flight data. So here's a slightly expanded view of the data that we have. And I wanted to take you through my thought process. If I was going to actually prepare this data set to go into the model, what would I do in terms of feature engineering? So the arrival delay is our target. And then if you look at these features, I'm going to go through them and say, would I actually include them as inputs to the model or not? So if we look at carrier, so carrier is the actual airline, do we think that that's worth putting into the model? With our domain knowledge of flights, would I say that carrier was a feature that I think would have an impact on whether a flight was delayed or not? And I believe it would be. Some airlines are more on time than others. So yeah, I would absolutely put a tick at the bottom there and say, oh, I'm going to feed that in. Would I include the flight number? So the flight number is a little bit too specific, because what we're looking for here in the feature set is columns that are generalizable to new data. The flight number, by definition, is just about one particular flight. So potentially the model will learn very specifically about each flight, but you want it to be a general model that you can feed in. So I would leave flight number out, because I think that wouldn't add any value to the model.
Excuse me, Russell.
Yes.
There's been a question in the chat from Mark Otten. He said, regarding feature engineering, he wants to know, how would you manage the risk of unintended bias from entering the model at this step?
That is a fantastic question. So we talk a lot about bias in machine learning, because often we introduce bias into the model without even realizing it. And one of the keys to that is to make sure that you are representing all of the features that you should be. So obviously a classic example here is when you're looking at certain models that might have to do with race, for example. You want to make sure that you've got representative data sets across your entire population, to make sure that you don't introduce inherent bias into the model. We could spend an hour talking about bias in and of itself, because it's a really important topic. We've got a couple of papers that we've actually written about that, because we believe it's very important. So we can include those in a follow-up email. Maria, I'm assuming we can follow up with some links, etc. after.
Oh, absolutely, that would be like really lovely. I'm happy to include it in the board as well as send it to participants.
Yeah, thanks. Because that's great question, because it's a really important topic. So, do we want to include the origin airport? I think we do, because that's going to have definitely a factor on whether planes are delayed or not. Do we want to include the origin airport ID? It's just redundant, really, because it's exactly the same as the origin information. Similarly, destination is important. ID of the destination is redundant. Now, with this column that's about cancelled, what do we want to do with that? So we don't really want to include that in the model, because if a flight's cancelled, then it doesn't actually fly anywhere. So we're actually going to filter that out. So when we start to look at our training data set, when we're preparing the training data set, we would then want to filter for flights that were not cancelled. Is the distance that the flight travels important? I would say yes. Now, what about the flight date? How important is the flight date? So the date, as it looks there on the screen, is actually not particularly useful, because again, it's a little bit specific that was the actual date that flight took. However, if we parse extra information out of that date, then it could be interesting. So the date can tell us things like the day of the week, whether it was a holiday or not, whether it was what season it was, and those things definitely do start to impact our model. So I would parse the flight date, and similarly with the time as well. The time is very specific, but you'd imagine that the time of day would have a big impact on a flight. So if you're flying on a busy Monday morning, for example, that's going to be different to flying in the middle of the day on a Wednesday. So again, with your arrival time, just parse that column, maybe put it into buckets, 10 to 11, 11 to 12, et cetera, and the model can then start to use that information. So that's kind of, in essence, feature engineering. Look at the data that you've got. What do you want to feed into the model? What do you want to break apart and make it a little bit easier for the model to actually start to learn from? Now, just a little diversion into the parsing piece, because this is quite interesting. So if we did want to take that date and parse it out a little bit, I've used kind of SQL notation here, but I think a lot of you would be familiar with this kind of thing, where we just want to extract the day of the week from the date and the month from the date as well. So what we feed into the model then is not the actual date, but we feed in the day of the week and the month. And then we can start to see those, some of the features around, a weekend's going to be busier than weekdays. Is a winter month going to have bigger impact on flight delay than, say, a summer month, for example?
Russell, there's been a few questions in the chat. And one is already about essentially getting rid of that black box label. So he's asking, as company of finance and business analysis, how do you develop adaptable models to make users quickly understand? So how do you create models where that are less like a black box and more understandable for, say, layman's, and if you have to base business decisions on them?
Yeah, again, that is a fantastic question. So this falls under a heading that we call explainable AI, where you want to do exactly what you're suggesting, which is you want the model to give you a prediction, but you also want to know, well, why did it predict that way? What kind of decisions was it making? And so when I show you the demo later on, one of the things that you can look at, there's a number of different ways that you can do it, but in the types of models we're talking about here, you can actually see the model will actually give you the weights for each of the features. So it will say, for example, it weighted the day of the week particularly highly in the model. And so then you can start to see which of your features are then leading to that outcome. But that whole piece around explainable AI, again, extremely important. Was there another question as well, Felix?
Yes, Kushwant, hope I pronounced it correctly, would like to know what is the procedure to make sure that the model is successful without bias, error, or a lack of knowledge of the model creator. And I would like to just input there that if there is a lack of knowledge of the model creator, then there's no way to avoid bias. That business knowledge is necessary for model creation. And so Russell, you can take the rest of this question.
Yeah, so yeah, you're absolutely right. The more you know about the data, the more you can avoid bias, and the more you can be smarter about what you feed into the model. Now, in terms of the accuracy of the model, that's one of the key steps that you want to look at. Once the model's been trained, the next step is then to test the accuracy of the model to make sure that it's actually making predictions that have sufficiently high accuracy for you to actually use. Now, the thing about the accuracy is it doesn't necessarily show you bias. Bias is a slightly more difficult thing to determine, so you need to do a little bit more work on that. But in terms of when we look at evaluating the model, that's going to show you actually how good is it at actually predicting. And we'll look at that in a sec. So yeah, so we've looked at feature engineering. Absolutely critical step that that often gets overlooked and is absolutely key to a good model. Now, there's another step which is pre-processing, and this is a bit more mechanical. It's less about your knowledge of the data, and it's a little bit more about just getting the data into a format for the model. And what I mean by that is that there's a couple of rules of thumb here, which is that most machine learning models, because it's all mathematics underneath, they work on numerical values. They need numbers in order to be able to perform what they're doing. And the second thing is that in a model, numbers have value. Now that sounds like a very obvious statement, but I'll show you how you can sometimes trip up if you don't keep that in the back of your mind. But for a model, if you feed it a numeric value, it will treat it with value compared to other numbers. So let me give you an example of that. So let's say, back to our feature engineering around the date. So we've pulled out that we want to feed into the model the day of the week for each of these flights. And we're going to turn them into numbers. Now, if we feed that into the model will then assume that, and let's assume for our purposes that the day starts on Monday. So Monday's 1, Wednesday's 3, Saturday's 6. Now, in our human heads, we're able to then categorize that. So we look at number 1 and we go, oh, that's a Monday, 3 is a Wednesday. We're looking at it as categories. But the model will potentially look at it as values. So it will think that a Wednesday is 3 times more valuable than a Monday, and a Saturday is 6 times more valuable than a Monday. Now, you could argue that that's kind of true, but we actually want the model to treat these as categories. So the way that you do that is that you actually feed it in this way. So you end up using Boolean values as opposed to a numeric sum. So basically, is it a Sunday? Yes or no. Is it a Monday? Yes or no, etc. Now, a lot of the tooling that I'll show you does this for you automatically, so you don't have to do this. But I love talking about it because I think it's interesting to just understand how the model's working, but also because the name of this approach is I really, really like. So it's called one-hot encoding. And I feel like the machine learning community has cornered the market in cool sounding names that would actually make good rock band names as well. So I don't know about you, but I would go and see One Hot Encoding if they were playing Saturday night. I'd be there. I'd be there for One Hot Encoding. And then this next step then is splitting the data up before we train it, training, and then evaluating it. So splitting the data set, what that means is that when we give our training data to the model, we want it to train, but we also want to get a feel for how accurate it actually is. So what the model does is 70% of the data that you give it, and these numbers are obviously, you can change these, but this is kind of the rule of thumb, is roughly 70% is used for that kind of training step where it's looking for patterns, and that creates the model. 30% is then held back, not used for training, but is then used for evaluation. So what the model will do is it will use that 70%, create the model, then take that 30%, which has still got the answers in it, because it's our training set, and it will then feed that through the model, make a prediction, and then compare its prediction to the actual answer, and then it will give you an accuracy score at the end. So to the question before about how do you make sure the model's actually working correctly, this doesn't show you bias, but it does show you the accuracy of prediction just by running a new data set through, making a prediction and comparing it to the results. And there's lots of different accuracy scores depending on the types of models, but then interpreting those is key to making sure that you've got a model that's actually making sense. And again, this splitting of the data set, a lot of tools will do that for you automatically. So you don't necessarily have to do that manually yourself. You just feed it the whole training data set and it will then split this for you. And then that last step is then just, if you're happy with the accuracy, deploying the model and then making predictions. And this is typically done in two different ways. You can either do it in batch or what's called online prediction. So batch is where you've got your model and you want it to then look at an entire spreadsheet full of numbers and give you predictions. So doing a batch of however many, 100, 1,000, 10,000. Online prediction is where you want to make a decision very, very quickly. So within 100 milliseconds, for example. So if you think of like a fraud example where you want to feed the model, here are the attributes of my transaction, the amount, the location, how well do we know the user, et cetera, et cetera. And then the model will say, actually, we think this is fraud and maybe stop the transaction. That you want to do in near real time. And so that's typically referred to as online prediction. So that's kind of the some of the key steps that you take in creating the model. What I wanted to do now is show you 3 different demos that take you through how you might actually use some of this different tooling. Now, the first demo, let me just set it up, give you a little bit of background. So the data set we've got is based on this, in the US, this is the bottom half of New York City. There's a whole bunch of bike rental stations where you can turn up, rent a bike, and then you can ride for as long as you like, and then you can then drop it off at any of the other stations, and you're good to go. So what we want to do is we want to look at the history of how many rentals were done on a particular day. So we're going to feed the model 2 years worth of history, and then we actually want it to make a prediction for us about the next 12 months. Now, in the demo, we're going to treat all of the stations together. So basically, we're going to come up with a number of predicted rentals across the whole of New York. But in reality, we can actually go a level deeper than that quite easily and then get demand for each of the individual stations, which would obviously be a little bit more interesting. But just for the purposes of the demo, I just wanted to kind of sum them all up for you. So that's the data set. Now, what we're going to do is do this from a spreadsheet. Can you see that? Can you see the spreadsheet now? Yep, cool. Thanks, Paul. So in the spreadsheet, Very, very simple. We've got two columns. The first column is the date, and the second column is the number of bikes that were rented out on that day across all the stations. And this is 2 years worth. So if I go to the bottom, so it's from the 1st of the 1st, 2014, down to the bottom there, which is the last day of the year, 2015. So we've got 2 years worth of data. And what we've done behind this spreadsheet, we've actually put some logic in that will actually call one of the back-end services that we have to do the training of the model and then to actually do the prediction for us as well. So I've already done the training bit because that usually takes a little bit longer. But then I actually wanted to show you it actually doing the prediction for us. So the first thing I want to do, let me just go back to the top here. So let me just show you what this looks like if we graph it. So let me put a chart in. So this is the data that we have. So this is the training data. So you can see two things in here. You can see the seasonal trends. So this is 2 years worth. So you can see that obviously being New York in the summer months, which is kind of in the middle of the year around June, July, there's much higher demand than in the winter months. And you can see that kind of really drops off around the end of the year and January, February, which is what you'd expect, right? No one wants to be riding around in the snow. And so that's what that kind of curve is. And then the individual ups and downs are the weekly changes that you see. So obviously weekends are going to be much busier than weekdays. So that's the training data set. So we've trained that on the back end. So what I'm going to do now is I'm going to go down to the bottom here. I'm going to put my cursor there. So what I'm going to say now is I'm going to ask this to forecast for me, and it's going to ask for how many time steps do we want to forecast. And so in this particular case, our time step is a day. So I actually want to go a year into the future. And it's going to then, so it's calling the model and it's pulled those values back and put them into our spreadsheet for us. And so we've now got from the 1st of the 1st, 2016 to the end of that year. And so it's updated our chart here. So you can see 1st of the 1st, 2016 onwards, these are all of our predictions. This last third is the predictions. And so you can see that it's obviously picked up the seasonality in that data. It's picked up the weekly changes as well. This is called a time series model, where it's very much based on a set time period, in this case a day, but it can be any time period you like. It could be hourly, monthly, yearly, whatever. And is typically done for demand forecasting, where you've got something that happens on a regular time basis and you want to know what's the demand going to be for a particular thing, or what's the value going to be on that day. So I wanted to show you this because often the entry point into machine learning can seem a little bit obscure, whereas if you've got a front end like a spreadsheet, if that then talks to the services at the back end, then obviously that makes it much easier for you to manipulate the data in a format that you're comfortable with. Any questions on that time series model?
There was one question on why you use 2 years of data in the history.
That's a good question. So typically, not always, but typically, the more data you can train on, the better model you'll get. Now, obviously, that's not always true. So let's say, for example, we knew that in 2014, we knew that there was some kind of event in New York, for example, that meant that those values were not going to be representative going forward, let's say there was a lot of construction or whatever, then it may not make sense to include that in the data set. But if you feel like the data would be a good predictor going forward, then typically you're better off training on a larger data set than a smaller one, because then you generally get a more accurate model. So that's time series through the spreadsheet. Now, the second demo I wanted to show you was that if you wanted to go get a little bit closer to the tools, for example. So I'm going to go into, this is the console that we have, and this is a part of the tooling called AutoML, where it's designed to, again, make it easy for you to use, but gives you a little bit more control. So I'll step you through the creation of a model, and then in true cooking show style, I'll go back to one that I prepared earlier. So let's say we want to create a model, going back to our flight example, that basically does exactly what we were talking about in the example. We want to have a model that's going to predict for whether a flight's going to be delayed or not. So in this particular case, we're just going to create a new we're just going to create a new data set. Let me call this flights demo. And you can see here there's a number of different types of machine learning models we can choose from. So there's image recognition, tabular, which we're going to look at, text classification, which I want to show you in the demo after this one. And then you can also do it for video as well. So probably, I'm guessing, less applicable in finance, but yeah, some really interesting different use cases you can do with video as well. So for us, it's tabular. So we're working on this very structured data set. We want to do a regression problem, which is basically just we want to predict a continuous number. And there's a number of ways we can get the data into the data set. So we can either, you'll see here in a sec, we can either upload a CSV from here. So let me make this a little bit bigger for you. So I can upload a CSV from my computer. I can upload a CSV from cloud storage, which is just the storage area that we have in cloud, or I can actually select an existing table from BigQuery, which is the database that we have in the cloud. Now, it so happens that I have my data sitting in a BigQuery table, so I'm going to use that. So let me just quickly pop that in. And that's going to look at the table, and it's going to pull out, you'll see these are the columns that are in that table. So we've got the arrival delay, carrier, et cetera, et cetera. And what we can then do is we can go over here and we can say, I want to train a new model on that. And the first thing it's going to ask us is, are you trying to classify something? So you're trying to say, are you trying to come up with either a yes or no, or maybe a multi-class? So maybe do you want to put these answers into 5 or 6 categories, or regression, which is more about a continuous numerical value, which is what we're after here. And then it's just going to ask us for the target column, in this case, the arrival delay. Okay, and you can see here that under this transformation column, so a lot of that pre-processing I was talking about, that will do that kind of thing for you automatically, or you can actually say, I actually want to have some control over that as well. And then we hit continue, and then it's basically going to say, how long do you want this model to run for? And again, similar to the how much data should you use, typically speaking, not always, but typically the longer you run that training step for, the better result you get. But you can set a budget here, so you can say, I only want this to run for an hour, and just show me the best result you've got after an hour. So I did that. So I ran that for an hour, and I wanted to show you the results of that. So if we come over to here, so this is now the model. The model's been trained, and now I can actually test the model. So in here, if you can see down the bottom here, I've got this test your model option, and it shows me all of the features that I pushed into the model, the carrier, departure delay, etc. And then I can actually hit predict, and it will push those values into the model and give me a prediction result. So what this is telling me is that if the flight is an American Airlines flight and it's going from Columbus, Ohio to Dallas, Fort Worth, and it leaves 5 minutes late, it predicts that it will actually arrive 2 minutes early based on 2 years worth of history that it's looked at before. And so we can kind of test it that way, and then we can look at the model properties. And this is where I think, no, not there, maybe here. So I wanted to show you this. So this is the feature importance. So to the question before about explainability and bias, etc. So this shows us the importance that the model is placing on the features. And no surprise that the biggest weighted feature, so the thing that has the biggest impact on whether a flight arrives late, is whether it leaves late. So that departure delay, you can see, is the most important feature for the model. And then after that, how far it has to taxi, and then the actual origin is also a big factor in whether a flight will be delayed or not as well. And carrier actually less than you think, not quite as important as you think. So having that ability to look at that feature importance is crucial when the model makes a prediction and you want to understand why it did that. And then from here, obviously, we can say, hey, we want to do a batch prediction for every flight that's coming up in the next 2 days, or we might actually want to have that online prediction where we want to have the ability to say, this flight's leaving in 30 minutes. Here's all the features I know about it. What do you predict in terms of its whether it's going to be on time or not? The last demo I wanted to show you is slightly different in that we're going to move away from the highly structured rows and columns type of data and talk a little bit more about free text. Now, you might think, well, what's that got to do with the finance community? But there may be times when actually being able to classify a block of text in a certain way could actually be beneficial. So the classic example of that is, I was talking to a customer the other day that they have a problem where they look at the expenses description. So people put in their expenses, they look at the description, and then they need to choose the right expense code that goes with that. And getting that wrong just basically delays the whole process. And then people get their expenses paid late and everyone gets upset. So being able to have some kind of automated approach where you could actually look at the text that someone's put in for an expense claim and then classify it based on the labels that you've taught the model could be very beneficial in keeping that process running smoothly. So the demo I want to show you is using the natural language model that we have. And I wanted to see, when I was setting this demo up, I was thinking about what kind of data I could use. And I wanted to see whether I could create a model that would look at the description for a movie and work out what genre that movie was. And so I found a data set that had 40,000 descriptions of movies and then categorize the genre of those movies. And I use that as my training data set. So the first thing I want to show you is a generic API and what that comes up with versus one that's trained for your particular data set. So we have a bunch of generic APIs, and one of them is a natural language API, and you can try this out just on the website. And this model is trained with generic data. And so the idea is that it's very easy to use. You don't need to train it with your own data. You just give it a block of text and it will then classify it, give you sentiment, etc. So let's give that a go. So I've got a description for a movie here, and 10 points for anyone who can guess what this movie is. And if we analyze it through, thank you, Mark. very quick off the mark there. That is indeed Mrs. Doubtfire. Now, if we analyze that through the generic API, it will give us some information about the entities that it sees in here. There's an actor, there's a housekeeper, there's a wife, children, etc. All the nouns. It will look at the sentiment within there. So it'll kind of talk about the sentiment and the magnitude of that sentiment. If you're into understanding the syntax, it'll pull out the syntax. And then what we're interested in is the category. So how does it classify it? Now, because this is a generic data set, we've got about 700 odd categories that we use to classify content. And so you can see it's chosen law and government, and then a subcategory of legal, and then we've got relationships and families, etc., etc. So it's kind of, it can only predict on what it's been trained on. So then I took my data set and then moved it to the AutoML version of this generic API, which allows you as a customer to train the model and push it in the direction that you want it to go. So give it more information so that it can then start to classify according to your particular taxonomy. So I did that. So this is the AutoML natural language page, and I fed in the data that I'd found that had the description and the genre. I trained it, and then I wanted to show you the results of that. Now, one of the things about this data set was that I didn't do any feature engineering at all, other than some of them had multiple classifications for each movie, and I removed the multiples and just had one for each. And so what I ended up with was a model that wasn't particularly accurate. I could have done a lot more work on that data set to really trim it up. And you can see here, this is called the, quite aptly, this is called the confusion matrix. And when you're looking at models like this, this gives you a really good indication of how the model's going. So across the top, we've got the predicted label for each of the when the model was testing itself, and down the left-hand side we've got the actual label. And what you want is you want this diagonal line across the middle to kind of be really strong. So for example, you can see if you look at drama, so for movies that were labeled as drama, where they were actually drama, the model 68% of the time said that they were drama, which is great. But it got a little bit confused around, it also thought that foreign films were also classed as drama, got a bit confused with romance and drama, etc. And this is partly due to me taking the multiple labels and condensing it down to one. So yeah, so the bottom line is I could have done a lot more feature engineering and ended up with a more accurate model. But let's test it, just conscious of time. So let's put our Mrs. Doubtfire text in here again. And let's see how the model goes. Okay, so you can see here, that the top two labels here, or the top label is comedy, and the second label is drama, which is pretty close. Like you class it as a comedy first and foremost, but there is some drama in it, which is interesting given that if you read that, if you didn't know the film and you read that blurb, comedy is probably not the first thing that would spring to your mind. But the model has seen enough of those types of blurbs to kind of get a bit of a feel for it. So I thought that was an interesting example to show you that you can also use machine learning for free text and more unstructured data as well, if that makes sense with your particular use case. And as I said before, obviously you can get into image recognition and video recognition and all sorts of fun stuff in that realm as well. Probably not as applicable to your types of workloads, but still an interesting place to explore as well. So I've only left you 4 minutes for questions. I'm sorry about that. I wanted to make sure that we got some demos in though, just to kind of show you the technology in action. I hope that gave you a good intro and a good kind of understanding of where it might fit in your environment. Any other questions before we finish up?
There was one last question that, well, there's two more questions. One that is, can these be used to summarize a book or a page? And the other one is this free for personal use, or what is the price point to use this platform?
Yeah, great question, Mark. So on the first one, in terms of summarization, if that block of text gets a bit too large, we'd probably use a slightly different model. So we do actually have a different model that is designed specifically for summarizing large amounts of text into a paragraph, for example, or a much smaller bite-sized piece. So it would use some of this as the underlying piece, but there's a little bit more nuance if you're trying to do a summary. But yeah, that's obviously a very interesting use case as well. And in terms of free for personal use, so if you create, you might know this better than me, Paul, I think if you create an account on Google Cloud, you get $300 of credits to use on whatever services you like. So you can certainly use that. And a lot of the services have a free tier as well, so that if you don't go over a certain threshold every month, then you don't pay for it. And those thresholds are reasonably generous if you're just playing around with it and having a look for personal use. So yeah, if you jump onto the Google Cloud Console, you can get that chunk of credit to start playing with it. Thank you, Mark.
Thank you, Russell. That was really, really interesting presentation with lots of examples. I think this is what was missing us usually, or when people understand how awesome is the tool, but they don't really see the practical application. That was really a fantastic presentation, giving lots of insights for the actual use for the tool. So definitely. I hope that our participants would love to connect with you later after the presentation. So I would like, if you mentioned that you have some materials that you'll be posting, please feel free to pass them to me, and I will be happy to post them on the wall on the board for Meetup group, as well as distribute to participants. Thank you so much for coming. That was absolutely fantastic presentation. Thank you.
Thank you so much, Maria, and thank you for joining us, everyone.
Thank you, everyone. Thank you for coming to the session. Hope to see you to our next session. And Russell, I would definitely want to invite your team to our next presentations. Thank you.
Thank you, Maria. Pleasure.